In this section, we will learn how to find arc length and the curvature of the curves. Now, let's look at a curve on the plane. How do we find arc length? Say here is a point A, t equal to A, we got this point, and t equal to AB, we got that point. Okay, how do we find the length of the curve? We don't know how to do that. However, we do know how to find the length of the straight line. So what we can do is break this curve to many small segments, and such that small enough you can find this straight line, the length of that line, and use that to approximate your curve. Okay. So we call this length is ds. So this is the dx and this is the dy. Okay. So your ds, use Pythagorean theory, should be dx squared plus dy squared. Okay, ds is this one. Okay, then add them together for all this segment. Then this gives you approximation to this curve, and this approximation is going to get better and better if you make this things finer and finer. So you take a limit. So that's exactly the definition of the integral. Okay, ds dx squared plus dy squared, and this one you can divide it dt dy dt. So you divided dt square, then you have to multiply that. Out of the square roots give you dt. Okay, t equal to a give you the starting point, t equal to b give you end point, and you find arc length, which we call L. Okay, so for the plane curve, this is the formula to find arc length. In the general, if I give you a curve in the space, that means I give you vector function. I give you curve, say t there between A and B. This is equivalent to say I give you the parametric form. X equal to ft, y equal to g sub t, z equal to h of t. Okay, so by the reason I explained to you, the arc length for the curve in the space similarly is like this: dt square plus dy dt square and plus dz dt square, then dt. Just add one more variable. And from here you can see dx dt give you f prime of t, right? And the dy dt give you g sub prime of t, and the dz dt give you h prime of t. So therefore, this is equivalent to say you have f prime t square plus g prime of t square plus h prime of t square dt. Okay, this is the formula to find arc length for the given curve by vector function r. And there's a shorter way to write that. That's r prime t dt. Why that? Because r prime t, this is a vector. What is r prime t? R is a vector function, so it's a derivative. So you take a derivative of each one. And its magnitude is square root f prime square plus g prime t square, there's t here, plus h prime t square. Okay, so we got a formula to find arc length for the given curve. Okay. Now let's look at the example. I give you a vector function like this. Cosine t, sine t. My t here is between 0 and 2 pi. Okay, since I have two variables here, I have two components. That means we have plane curve here. Okay, what this curve looks like. As I told you, this is a plane curve. You can do something, get rid of t. So this means x equal to cosine, let's put a here, okay, sorry. Put a here. X equal to a cosine t, y equal to a sine t. So if you take square on both sides, you are going to end up x squared plus y squared equal to a squared, which, as you know, give you a circle as a origin, as a center, as a as a radius. 1t equal to 0, they give you this point. 1t is increasing there all the way here. T equal to pi over 2, you got this point. And keep increasing, and 1t equal to 2 pi. They go back to that point again. Okay. So, if we want to find circumference of the circle, then that means we want to find arc length. Okay. So, let's find arc length. Arc length formula is from here, t from 0 to 2 pi, and r prime t dt. So now let's find what is r prime first. Okay. Derivative of vector function is take derivative of each component. So give you negative a sine t and a cosine t. And its magnitude is square root negative a sine t whole thing square. Give you a square sine square t plus a square cosine square t. Let's give you square root of a square, because sine square t plus cosine square t give you 1. So give you a. Okay. So the circumference of the circle is r prime t magnitude, which is a dt. You integrate that, give you at, evaluate 0 and 2 pi. Replace t by 2 pi, subtract, replace t by 0. So you end 2 pi a. That's exactly the formula to find arc length for the whole circle. Okay, think about it, you have a curve here. 1t equal to a, you got this point. So from a to t, I use u here, since I already used t here, du. This S here is a function of t. Okay, for given t, for example, t for some t, we got this point. So the S here is this arc length. Okay. Special case, for example, this point is t equal to b. If you let t equal to b, they give you the total arc length from point A to B. Okay. So for given different t, you can use this formula to find S, which is arc length from this point all the way here. Using the fundamental theorem of the calculus, this gives you r prime, vector. Okay, now let's look at an example. This example, we want to parameterize the curve. I give you a vector function, means I give you a curve. This is a cosine t I plus sine t j plus t k, or you use a triple to describe this vector is cosine t, sine t, and a t. I prefer use triple, it's simpler to write. Okay, what we want to do, we want to parameterize this curve. In the other words, we want to, okay, here we want to use, we don't want to use t as a parameter. We want to use arc length s as a parameter. Okay. So to do that, we need to find a relationship between s and t. Okay, we know s and t are related like this. Okay, they want us, you have to say your arc length count start at which point. They said count as 1, 0, 0. When t equal to what? Give you this point. Obviously, when t equal to 0, then you plug in r 0, give you cosine 0, give you 1, sine 0, give you 0, and 0, give you 0. Okay. So we want to count our arc length. Start with t equal to 0, then to t. R prime t u du. Since u here is a dummy variable, you can use any letter you want. Since we already used t here, okay, so we want to use different letter. Okay, so first of all, we have to find what is r prime t. Find the derivative for the given vector function is find each component. Cosine t, take derivative, sine t. Sine t, take derivative, cosine t. T, take derivative, give you 1. Then we find its magnitude. Is square root negative sine t square plus cosine t square, then plus 1. Sine square t plus cosine square t give you 1, so total is square root of 2. So s and t, they are related this way. I substitute r prime u by this derivative is square root of 2. Okay. Then du. So give you square root of 2 u, evaluate 0 and t. So replace u by t, give you square root of 2 t. Subtract, replace u by 0, give you 0. So from here we get t and s related. T is equal to s over square root of 2. So we put back in the equation. T is a function of s. Okay. Is equal to cosine t, which is s over square root of 2. Sine t is s over square root of 2. then t is s over square root of 2. So this means whenever you give me s, I can tell you the point on the curve. Okay, next let's look at the curvature. How do we find the curvature? How do we define the curvature for a curve? Okay, remember we have vector t. What is vector t? Vector t has been defined as r prime t divided by its magnitude. So I give you r's of t. That means I give you a curve. And r prime t give you tangent direction. And the capital T has same direction with r prime t, which means also tangent direction. However, its magnitude is 1. Okay, the curvature of a curve has been defined by the magnitude of dt, d capital T, ds. Okay, capital T is a vector. Okay, you take a derivative, still vector. And so we take its magnitude, give you a scalar. Okay, remember capital T. Now think about a curve here. Capital T is a tangent direction. Its magnitude is 1. Different point, you got a different tangent direction. So when your arc length is increasing for this curve, your capital T is changing. Okay, since the magnitude is 1, when t is changed, that means only change direction. So this k here describes how fast your direction changed when arc length is increasing. So measure the curvature of your curve. Okay, the definition. This definition makes sense. Okay. However, this formula is not good. It normally is not very useful to find curvature because your curve normally is given by any t. See, this is the arc length, so you have parameterize, then you can take a derivative. So we want to, this is the definition. Okay, now we want to find a formula. It's more easier to find the curvature. Okay. Now, t is any parameter, so this one's easy to find. And this one using chain rule give you dt ds, then ds dt. And therefore dt ds is equal to dt over ds dt. Okay, therefore the magnitude of that is equal to, this is a scalar, okay, denominator is scalar. So this will give you t prime t magnitude. You take a magnitude of the whole thing. And we just said that ds dt use fundamental theory of the calculus give you this. So we got a formula like this, which is easier to find the curvature. This is your curvature. Okay. Because we normally use, arbitrary t as a parameter. And also, if you don't want to, if you only know rt, we have another formula to find the curvature. You said I don't find the capital T. Then you can use this formula. Okay. If they want to find the curvature, they have to give you the curve. Okay. So by giving this one, you can plug in here, take a first derivative, second derivative, and do the cross product. You can find the curvature. Since this is just plug in the formula, so I don't think it's necessary for me to give you example for that. I still strongly suggest you need to read the book for the details.